Let's take a look at this analytical geometry question. The question reads, in the diagram, M is the center of the circle. The circle cuts the x-axis at N. ST is a tangent to the circle. R would D greater than 0 and L lie on the circle. O and V are the x-intercepts of PL and RL respectively. 4.1, write down the coordinates of L. Okay, so L is our point right here, and you could use the midpoint formula because you know the point M and you know point P. So you could use midpoint formula, though I want to use a different method here. And it's actually a quicker method if you think about it. So what we do is we look at the distances vertically and we look at the distance horizontally. The distance vertically is 9 minus 3, which is 6. And the distance horizontally is going to be 3 minus 1, which is 2. And since M is the midpoint, we can then slide this triangle down here, and the distances vertically and horizontally should still be the same. So 6 here, and then 2 this way. Now, since we're going down, we will subtract. So the y value is going to be 3 minus 6, which is negative 3. So L is going to be something and negative 3. And then horizontally, since we're going to move to the left, we're going to subtract again. So 1 minus 2 is minus 1. So the coordinate for L is minus 1 and 3. Again, you could use the midpoint formula and you'll still get the same answer. Question 4.2. Determine the equation of the tangent ST to the circle at P. Okay, let's just clear this up again. Write down our coordinate here, minus 1 and minus 3. Now they want to know what is the equation of this line right here. So first thing we need to do is work out the gradient. We don't know the gradient, but we do know that the radius and the tangent are perpendicular. So if we work out the gradient of the radius, we can then get the radius of the tangent. All right, so let's work out the gradient of MP. That's going to be y2 minus y1 divided by x2 minus x1. Now, it doesn't matter which points you choose here as your x2 and y2 or x1 and y1, as long as you remain consistent. So I'm going to choose 9 minus 3 divided by 3 minus 1. That's 6 divided by 2, and that's 3. Now we know that the gradient of MP multiplied by the gradient of ST is equal minus 1, since they're perpendicular. 3 times the gradient of ST is equal to minus 1. It means that the gradient of ST is equal to minus 1 over 3. Now we can use this formula to calculate the equation. Y minus y1 is equal to M into x minus x1. We know M is minus 1 over 3, and y1 and x1 just need to be a point that's on the line. And point P lies on the line, so we'll use point P. So y minus 9 is equal to minus 1 over 3 into x minus 3. So y minus 9 is equal to minus 1 over 3x plus 1. Y is equal to minus 1 over 3x plus 1 plus 9. Y is equal to minus 1 over 3x plus 10. That's our equation. Question 4.3, show that the equation of the circle with center M is x squared plus y squared minus 2x minus 6y minus 30 is equal to 0. Okay, now the equation of a line, or equation of a circle rather, when the center is not the origin, is going to be written in this form. So question 4.3 is going to be x minus x1 plus y minus y1, and these are squared, and that's equal to r squared. x1 and y1 are the coordinates of our center. So let's substitute that in. So x minus 1 all squared plus y minus 3 all squared is equal to r squared. Remember, r is our radius. We don't know the radius, so we can work it out though, because we know the coordinate of M and we know the coordinate of P. So to work out the radius, we can use the distance formula. So we're going to say that r squared, or the distance squared, is going to equal x2 minus x1 all squared plus y2 minus y1 all squared. Again, it doesn't matter which points you use as your x2 and y2 and so on, as long as you remain consistent. So let's quickly substitute. 3 minus 1 all squared plus 9 minus 3 all squared. That's going to give me 2 squared plus 6 squared. So r squared is equal to 4 plus 36, which is 40. So our equation is going to be x minus 1 all squared plus y minus 3 all squared equals 40. Now they want us to write it in this form. So to get that form, we need to simplify, or in other words, open up our brackets. So if we open up the brackets, we're going to get x squared minus 2x plus 1 plus y squared minus 6x plus 9 equals 40. Now we can take the 40 across, and that's going to give us x squared, and let's rearrange while we're at it. So x squared plus y squared minus 2x minus 6y here. This is 6y, not 6x. Yeah, sorry about that. So 6y. So minus 6y plus 1 plus 9 minus 40 is equal to 0. And we just need to simplify this, and we're done. So x squared plus y squared minus 2x minus 6y. 1 plus 9 is 10. 10 minus 40 is negative 30 is equal to 0. And we're done. Question 4.4, show that D is equal to 7. So D is this point right here. All right, and what we can do to work out D, since D lies on our circumference, we can use the equation. So our equation is going to be x minus 1 all squared plus y minus 3 all squared equals 40. Now at point D, at point R rather, this point, we know that the y value is 1. So let's substitute 1. So D is our x value. So D minus 1 all squared plus 1 minus 3 all squared is equal to 40. So this is going to give me D squared minus 2D plus 1. Then this simplifies as minus 2. And minus 2 all squared is plus 4, and that's equal to 40. Now let's transpose. So d squared minus 2d plus 5 minus 40 is equal to 0. Then we're going to say d squared minus 2d, and this is going to give me minus 35 is equal to 0. Yeah, minus 35 is equal to 0. And now we can solve. So mode 5, 3 on our calculator, 1, negative 2, negative 35. And our answer here is x is equal to 7. So this is going to be d is equal to 7 or d is equal to negative 5. Now remember they said that d is positive. So let's actually do our factors here. Yeah, so they tell us that d is positive in the instruction. So that means we're going to take the positive value and we're going to say that d is equal to 7. We will reject this. Okay, let's move on to question 4.5. Calculate the size of angle L. Okay, so question 4.5. If you want to calculate the size of angle L, here's a few ways we can do it. Now, we can look at the triangle right here. Let's highlight this triangle in green. So this triangle right here. And we can use some Euclidean geometry to help us work this out. So basically what we need to do is we can say that this line right here, that's my angle at the center. That's my diameter, right? And we can use angles in a semicircle to then work out what this angle here is going to be. So angles in a semicircle would tell us then this is going to be 90 degrees. Okay? If that's 90 degrees, what we then need to do is we can figure out what this length is and what that length is, and then we can figure out what the angle is. Okay? So let's go ahead and figure out the length of that line and figure out the length of that line right there. Okay, so we're going to do RP and then we'll do RL. So we can do this right here, just so it's easier for us to follow. So the length of RP is going to equal the square root of 3 minus 7 all squared, D was 7, and then plus 9 minus 1 all squared. Now if we put that in our calculator, RP is equal to the square root 3 minus 7 all squared plus 8 squared. That's 4 square root 5. So the length of this line is 4 square root 5. Let's work at the length of RL. So RL, we're going to say again, so RL is equal to the square root of minus 1 minus 7 all squared plus minus 3 minus 1 all squared. We put this in our calculator. So minus 8 all squared plus minus 4 all squared. That gives us again 4 square root 5. So this is an isosceles triangle. Okay, and we can sketch it out quickly here. We have our line like this, here and here. We know that that is 90 degrees. So if I call this X and I call that X, because it's an isosceles triangle, we can use some angles in the triangle to work out what the angle here is going to be, because that's what they wanted, angle L. So we can say that in this triangle, x plus 90 equals 180. That means 2x is equal to 90. That means x is equal to 45 degrees. So this angle right here is 45, angle L, and this angle right here is also going to be 45. Okay, so L is equal to 45 degrees. Now let's take a look at the last question. The last question reads, TR is a tangent to the circle at R. Prove that PT is perpendicular to RT. Now to solve this, I've drawn a diagram for us. So this is what we have. Here's our information. And basically what we want to show is that if it's perpendicular, if this line right here is perpendicular to this line right here, then all we need to do is show that this angle right here is 90 degrees. So that's all we need to do. Now we can work out this angle right here, right? We know that this is going to be that's my radius, and we know that the radius is going to be perpendicular to the tangent, but we may not be 100% sure as to what that angle is going to be. So what we can do is we can use the tan chord theorem. So tan chord theorem, this is the angle that the tangent makes to the chord, and it's going to be equal to the angle that is subtended, so here. So it's going to equal to 45 degrees. So this angle right here is 45 degrees, right? Next, coming up is we want to work out what this angle right here is. So we know that this line is the line drawn from the center, and we know that that's a tangent. So we know that this right here must be 90 degrees. And since we know that this angle is 45, it means that this here must be 45. So if we redraw the triangle that we're currently working with, we have a 45 here. So that's P, T, and R. We have a 45 right here. That means by some angles in the triangle, that must be 90. And so since this is 90, we can say that therefore PT is perpendicular to RT. And that's it. Thanks for watching, everyone. I hope you found this useful. I'll see you in the next video. Bye-bye.